KCL at point A, then so at point A, what are the incoming currents? I1,
I1
I2.
plus
These two
I4.
are the incoming currents. So algebraic sum of the incoming currents I1 plus I4.
I1 plus I4 is equals to I2 plus I3 plus I5.
Right. Algebraic sum of the incoming current should be equal to the sum of the algebraic sum of the current leaving from that junction. So which currents are leaving from point A? I2, I3 and I5. These three currents are going out from the point A. So algebraic sum of these currents, that is I2, I2 plus I5 plus I3. Okay, so this is the KCL equation for this circuit. So what will be the KCL equation for this? Oh, this was the KCL equation for this network. So what will be the, if we apply KCL at this point A for this network, then what will be the equation? KCL equation. So
I
applying
equals to
KCL
I1
at point A, follow? Yes,
I equals to I1 plus I2 plus I3 plus I4.
right. So what we can find out from this network diagram, we can easily find out that only this current I is the current which is entering at point A, and this I1, I2, I3, and I4, these are the outgoing currents. So as per the statement of the KCL, algebraic in any electrical network, the algebraic sum of the incoming current should be equal to the algebraic sum of the outgoing current from any junction, so that there will be no accumulation of charge in that junction. So I is the incoming current. I should be equal to I1 plus I2 plus I3 plus I4. So this is the KCL equation for these two networks. Suppose this circuit is given to you. This is one circuit. This circuit is given to you, and you are asked to find out the values of the unknown currents. Solve this numerical first. Find out the magnitude and the direction of the unknown currents. When I1 equal to 10 ampere, it is written that I1 is equal to 10 ampere. Write down. I2 is equal to 6 ampere and I5 is equal to 4 ampere. I1 is equal to 10 ampere, I2 is equal to 6 ampere, and I5 is equal to 4 ampere. Now find out the values of the other unknown currents. Let me find out the value of I3, I4, I6, and I7. Have you got the question? I1 is given 10 ampere, I2 is given as 6 ampere, and I5 is given as 4 ampere. Now find out the values of I3, I4, and I6, and I7 also, with the help of KCL. With the you can solve this. You can take the help of KCL also to solve this. So how to find out the values of the unknown currents? So first apply KCL at point A. For this circuit, if we apply KCL at point A, then we can find out the incoming currents I1 equation will be like this. Applying KCL at point A, we will be getting this equation. I1 is equal to I2 plus I4. Now the value of I1 is given in our question. So from that, the value of I1 is given, the value of I2 is also given. So the value of I4 can be obtained by applying KCL at point A. Now if we apply KCL at node B or at point B, then also we can find out one equation. We will be getting one equation. The equation is I5 is outgoing current, I3 is also the outgoing current, and I2 is the incoming current. So I2 is equal to I5 plus I3. The value of I2 is already given in the question. The value of I5 is also already given in the question. So we can find out the value of I3 by applying KCL at node B. Similarly, if we apply KCL at node C, then we will be getting one equation, that is, what will be the KCL equation at node C?
I5 plus
I5
I6
plus
equals to I7.
I6 is equal to I7.
Right, I5 plus I6 is equal to I7. So if the value of I1 is given in the question, if the value of I1 is say 10 ampere, so the value of I7 will also become 10 ampere, because I1 is the current which is entering in this part of the circuit. So this 10 ampere current will be going out from this part. So if I1 is 10 ampere, then I7 will also become 10 ampere. So I5 is given in the question, I think. I7 is 10 ampere. We can find out the value of I6. In this way, we can find out the values of the unknown currents by using KCL, by applying KCL at different nodes of the circuit. Now this one, if we apply KCL at node D, then what will happen? The equation will become like this: I4 plus I3 should be equal to I6. Now put the values of the known quantities, then we can get the value of the unknown quantity of the current. Okay, clear? In this way we can solve this circuit. Any question from this circuit, from this problem? Okay. Next is Kirchhoff's voltage law, KVL. So if we want to the statement of the KVL, first we have to know. The statement of the KVL is Kirchhoff's voltage law. The algebraic sum of the products of the current and resistances in each of the conductors in any closed path or mesh in a network plus the algebraic sum of the voltages or EMFs in that path is 0. Or you can say
Please say it again.
okay, so we can say that the algebraic sum of the currents, the algebraic sum of the voltage and the voltage drops in any closed path, that is equal to 0. That can also be called as the Kirchhoff voltage law. So if we take any example of any kind of circuit, so we can say that summation of IR is the voltage drop, and the summation of the EMFs in any closed path, that should be equal to 0. That is called the Kirchhoff voltage law. So to apply Kirchhoff's voltage law, we have to know the sign convention techniques and determination of voltage sign. In applying Kirchhoff's law to a specific problem, particularly attention should be given to the algebraic signs of the voltage drop and the EMFs. Okay, otherwise the result will come to wrong. So some sign convention is required to be known. We have seen this thing in the previous class also. So when we will be writing down plus IR and when we will be writing down the minus IR, that has to be known. Hmm. So this thing we have already discussed in the previous class. Let's see once again. Just a minute. So this is the thing. So here, I think we have already discussed this thing in the previous class. So sign convention technique. That means suppose one voltage source is present over here. This is a battery source. The long line is indicating the positive terminal of the battery, and the small line is indicating the negative terminal of the battery. Now this is the point A and B. If we move from A to B, then we are moving from minus to plus. So you can say there is a rise in the voltage or rise in the potential. So the polarity of the voltage source, the polarity of the voltage polarity should be plus before of this E. So what is the polarity of the voltage source? That is the positive polarity. Clear? As we are moving from A to B, so we are moving from negative potential to the positive potential, lower potential to the higher potential. So we can say that our potential is increasing. So there is a rise in voltage. That is why the sign should be positive before this E. Now, if the voltage source is connected in this way, this is the positive terminal of the battery, and this is the negative terminal of the battery. Now if we move from A to B, that means we are moving from negative to positive, positive to negative. So you can say that there is a fall in voltage. That is why the sign of the voltage source should be the polarity should be negative before of this voltage source. This is clear to everybody? As we are
Yes,
moving
sir.
from A to B, so we are moving from
Yes, sir.
plus to minus. So our
Yes,
potential
sir.
is decreasing, we can say. That is why this E should be having negative sign before of this. Okay, similarly, suppose one resistor is given to you and the voltage across the resistor is V and the current which is flowing through the resistor is I. Okay, so and we are moving from A to B. So that means we are moving from plus to minus. So the voltage drop which is happening across the resistor, that is I into R, V equal to IR. So the sign of this IR should be of minus as we are moving from plus to minus. So our potential is decreasing, we can say. That is why the polarity should be of negative. Okay, and for this condition we can say that we are moving from A to B, and this is and current is flowing through the current is flowing through the resistor from B to A. So we can say that so as current is flowing from B to A, so B should be positive and A should be negative. That means we are moving from negative to positive, so our potential is increasing, we can say. That is why the polarity of the polarity of the voltage drop across the resistor, that should be of positive polarity. Okay, so if we move from minus to plus, then the polarity will be of plus before the element. If we move from plus to minus, then the polarity will be of minus, because we are moving from plus to minus, so you can say that our potential is decreasing. Similarly, we are moving from plus to minus, our potential is decreasing. That is why the sign will be of minus. As we are moving from minus to plus over here, so our potential is increasing. That is why the polarity should be of plus over here. Okay, the polarity of the voltage drop should be of plus IR instead of minus IR. Suppose this type of configuration is given to you, and you are asked to write down the KVL equation for this circuit. you are asked to find out the KVL equation. Here the direction of the flow of the current in each branch is given to you. I1 current is flowing in this direction, it is given. I4 current is flowing in this direction. I2 current is flowing in downwards direction, and I3 current is flowing in this direction. It is given to you, and you are asked to write down the KVL equation. So if we start from the point A, and if we travel in if we travel in clockwise direction, so direction of travel it is shown here with the help of this arrow. So if we start our journey from A, and if we try to complete our journey at point A again, traveling in clockwise direction, then first which element comes? First the resistor R1 comes. So I1 current is flowing to the resistor R1. So what will be the voltage drop in R1? That is I1 into R1. I1 into R1 is the voltage drop which is happening in the resistor R1. Now as we are moving from A to B, as current is flowing from A to B, so this should be plus and this should be minus. Current is flowing from A to B. Current flows from higher potential to lower potential. So this should be plus and this should be minus. And we are also moving from A to B. So we are moving from plus to minus. So polarity of the voltage drop will be of negative. There is a fall in potential. It is clear. We are moving from plus A to B. We are moving from plus to minus. There is a fall in potential. That is why the polarity should be of minus, negative. Now if we move from B to C, so what will be the voltage drop and polarity across R2?
minus I2 R2.
Minus I2 into R2. As current I2 is flowing from B to C, so B should be plus, this should be minus, and we are also moving from B to C. We are moving from plus to minus. We can say our potential is decreasing, so voltage drop will be of negative. So I2 into R2, that is the voltage drop which is happening in resistance R2, that should be of negative. Should be of negative. After that, there is one voltage source come, E2. So what will be the polarity before this E2? And this is
Plus.
the positive plate of the battery. This is the positive plate of the battery, and this is the negative plate of the battery. Okay. So this is the positive plate and this is the negative plate. So and we are moving from B to C. That means we are moving from positive to negative, losing our potential. That is why polarity before E2 should be of negative. There is a fall in potential. Now if we are moving from C to D, but current in this branch C to D is flowing from D to C. So as current is flowing from D to C, so D should be positive and C should be negative. So and we are moving from C to D, so we are moving from minus to plus. So there is a rise in potential. So the voltage drop which is happening across R3, that is I3 into R3, that should be of positive. Why it is positive? Because we are moving from minus to plus. So there is a increase of potential, you can say. Okay. Now again we are moving from D to A. In this branch the current is flowing in D to A, so this should be positive and this should be negative. Through R4 current is flowing in upward direction. So this should be positive and this should be negative. And this is the battery source. This is the negative terminal. This is the positive terminal. So if we move from D to A, the sign before E1 that should be off. We are moving for the battery source. We are moving from minus to plus. We can say our potential is increasing. So this should be of positive. There is a rise in potential. There is a rise in potential. We are moving from minus to plus. There is a rise in potential. That is why this should be positive. Now for R4, the voltage drop in R4 that should be equal to I4 into R4. I4 into R4 is the voltage drop. So that should be up. So we are moving from plus to minus. Potential is decreasing. So there is a fall in potential. So this should be the equation. The polarity should be of minus for this I4 into R4 drop. Now if we want to write down the KVL equation for this entire loop, then the equation will be of minus I1 into R1 minus I1 into R1 minus I2 into R2 minus I2 into R2 here plus plus I3 into R3. It is written wrong over here. It should be plus I3 into R3 minus I4 into R4 minus I4 into R4 minus E2. The polarity of the E2 should be minus E2 plus E1. That should be equal to 0. So you can say that algebraic sum of the voltages and the voltage drops in any closed loop, that should be equal to the 0. Clear? So sign convention is known to us right now.